So from kinetic molecular theory, we came away with the idea that the average kinetic energy was proportional to the temperature, but you notice in that we talk about the average kinetic energy, not the kinetic energy. And that's because all of the particles in the sample actually don't have the same kinetic energy. There's a distribution of energies. Some of the particles are moving very fast, some of the particles are moving slow. On average, we know what their velocity is because that's what's related to the temperature. This distribution turns out to be very important for chemistry. It's very important because all the molecules aren't the same. Some of them have very high kinetic energies, and the ones that have very high kinetic energies will tend to do things that the others won't. They will be the molecules that evaporate because they have enough kinetic energy to escape the attractive forces from a liquid. They'll be the first molecules that react because they'll have enough kinetic energy to get over some barrier for a reaction. And all of this derives from the same idea that the kinetic energy is related to the temperature, but it's not an absolute kinetic energy, but a distribution. And the easiest place to see that is in a gas, where we can measure the velocities that the particles have, and we can see that on average they're related to the temperature, but there's always a distribution.